Welcome back everyone to this lecture on conditional filtering with pandas. Now we've already learned how to filter out columns or rows based off the position of those rows or the actual label name. However, typically in data analysis, our data sets are going to be large enough that we don't filter based off a position. We're not going to actually know what row is at index position 100, for instance. But instead, we typically filter based off a condition. And conditional filtering allows us to select rows from our data frame based off a condition on a column. And I'm being very particular with that phrasing of selecting rows based off a column condition, which leads to a larger discussion on how we should organize our data in general, especially when we start to move on to machine learning. You've already heard me talk about this data organization, but I just want to make it really clear because when we talk about conditional filtering, this is really where that organization starts to come into play. So we want to talk about organizing our data, and here we can see an example data frame. And the key thing to note here is that every single column is going to be what we call a feature. That is an attribute that is some sort of property or characteristic of every single instance, which is a row. So here we can see that we have a year feature, that year of independence, where every country would then have that year of independence in this data set. And then we have the population, how many people live in that country, another attribute, feature, characteristic. And then we also have GDP. And then when we think about the rows themselves, the rows are instances of the data. So every single row would then, in this case, be a particular country with certain characteristics or attributes described in the columns. And so this format is actually going to be a requirement when we start to apply machine learning algorithms to our data later on. So we want to make sure that whenever we're really dealing with this data, it's in the correct format. And if you ever want to kind of switch these, you can always transpose your data frame if for some reason your rows happen to be what look like features or characteristics and your columns are every instance. But in general, throughout pretty much any major database system or any way of storing data, we want to follow this sort of format where we have the rows as particular data instances and then the columns are features or attributes. Now this formatting allows us to directly begin to answer questions and perform data analysis, which leads to conditional filtering. So you may have a question like, what countries have a population greater than X? So let's talk about the actual syntax for doing this with pandas, and then we'll hop over to a Jupyter Notebook and explore it and code it out ourselves. Let's answer the question using pandas in this particular small example data frame of what countries have a population greater than 50. So what we need to do is we first need to locate what column are we actually going to filter on. And in this case, it's the population column. And we know we can select the column just by saying data frame and then in square braces pass in the column name. So here it's pop. So we have now this essentially column, which is a pandas series. And then what we want to do is compare it using a condition. So we were wanting to know what countries have a population greater than 50. And so we're going to compare this entire series directly, in this case, to a single value. And pandas is okay with that because what it's going to end up doing is it's actually going to broadcast that comparison to every single instance in this particular column. So I can see here that 328 is greater than 50, so that'll be true. 38 is less than 50, so that's false. And then 126 is greater than 50, so that's true. And what pandas is actually going to do is return back a series of Boolean values for every single instance where it was true or false. And now that we have these Boolean values, really what we're concerned about is since we wanted the rows for the countries where the population is greater than 50, we're essentially going to broadcast this series across the entire array for where it happens to be true. And the syntax for that is a little strange in that you're actually going to pass in this series of Boolean values back into your data frame in order to get this result. So let me just quickly kind of show you this visualization again. Don't worry, we will code it out ourselves. But again, the key steps is to first grab the column you want to perform the comparison on, perform the comparison, which gives you this series of Boolean values, and then you're going to pass in that series of Boolean values into your data frame, and then it's only going to select the rows where it happens to be true. So that happens to be here USA and Mexico. So then we have USA and Mexico as our final result. So that's the coding syntax, and this is how we can perform conditional filtering with pandas. So what we're going to cover right now is filtering by a single condition, which is what we just showed, And then we'll also show you how to filter by multiple conditions. Maybe you want all the countries where the population is greater than 50 and the GDP is greater than 200 or something like that. And then we're also going to show you how to check against multiple possible values. So you'll notice that we also have categorical columns sometimes, like, for example, what color is something, red or blue. And in that case, you don't perform comparisons like, is red greater than blue? Instead, you would say something like, only give me back the rows where the color happens to be in this list of values, where I want only red and blue colors back. So we'll learn how to check against multiple possible values. Very useful for categorical features. So let's head over to the Jupyter Notebook and show you how this is all done with Pandas. Alright, so here I am back at the Jupyter Notebook. I've imported NumPy and Pandas, and then I read in the tips.csv file again. Go ahead and reread the CSV file in as a new data frame, because we've made a couple of changes with new columns or grabbing certain rows. So just to make sure you can follow along exactly, go ahead and just read in tips.csv and then view the head. If you read it in fresh, you should be able to see the first total bill is that $16.99 one. So let's go ahead and show you how we can filter based off a single condition. First, let's say I want to grab rows where the total bill happens to be more than, let's say the total is more than $40 of this total bill. So how do we actually run this? Well, recall from the slides that we first grab the column that I want to filter by. So df total bill is the column. So I run this, and now I perform the actual comparison operation. In this case, I have a couple of options. I could say greater than, less than, or equal to, not equal to. So all those same sort of comparison operations you perform in normal Python, those are all available for us here within Pandas. And in this case, I want to know, where's my total bill greater than $40? So when I run this, what Pandas does automatically is it does this comparison of greater than 40 for every single row in this series. And then it returns back either true or false. So you notice the vast majority of these appear to be false, because that makes sense. The first bills here shown are less than $40, not greater than $40. And so what we have here then is this series of Boolean values. And the way I like to show this at first is by actually calling this Boolean series. And the main thing to note here is that each of these Booleans has an index associated with it. And so when we have this series of Boolean values, I can pass in that Boolean series. So just pass in that variable, Boolean series, into the data frame. And then what it's going to do is it's only going to return the rows where the Boolean series happen to be true based off the index position. So I know that in my Boolean series, the very first numeric index that happened to be true is index 59. So then passing this Boolean series into my data frame is going to end up returning row 59, along with the other rows where the total bill, we can see here, all of these are greater than $40. And I note here that I do this in two steps, creating the Boolean series and then passing in the Boolean series, because it's a little easier to explain that way. But typically, we don't actually need this variable reassignment here. Instead, I can just grab this guy of df and then paste it in here. And this is the way you're going to be working with Pandas as you get more and more comfortable with it. You just do this all in one step of saying df where the total bill is greater than 40, and then pass in that Boolean series into my data frame, so that when you run this, you get back those exact same results. And that is how you can basically do filter conditions on just one particular condition. So let's go ahead and try this where we want to know, give us all the rows where the sex happens to be male. In that case, the column I'm looking at is the sex column, and I want to make sure and do the comparison where it's equal to male. And then we run that, and now I can see that I only get back the male columns. So I would encourage you to just do a little bit of experimenting here on your own and see where you can find certain different conditional filterings. So the other thing we do is let's go ahead and choose where the size of the party is greater than 3. So simple, we just say take the size column and give me where it's greater than 3. And then those Boolean values get passed in to this entire data frame. We run that, and now I can see the size here, they're all 4 or more. Okay, so that's conditional filtering based off just one feature. But what if I want to base it off multiple conditions? This is where we're going to have to expand on this. Now there are two main ways of putting together multiple conditions. And the two main ways are with an AND operator, which is going to be an ampersand inside of Pandas, and we'll explain why in just a second. But for this one, both conditions must be true. The alternative is the OR operator, which is going to be a pipe operator in Pandas. And for this one, it can be either condition is true in order to execute. So we're already familiar with the and OR of Python. So this could be something like 1 equal to 1 and 2 equal to 2. So this returns true. And so what we need to do is basically convert this and statement and the Python OR statement into ampersands and pipe operators for this to all work with Pandas. So let's go ahead and kind of build out step by step how we work with multiple conditions in Pandas. So the first thing you need to do is have your data frame, and I'll be constructing down here at the bottom cell the total or the final line, and then step by step we'll do it on this cell above. So the first thing I want to do is begin by saying df square braces, and then I'm going to have two conditions that I'm going to pass in. So we can say condition 1 is df, and let's have this be where total bill is greater than 30. So that's going to be my first condition. And then the second condition I also want to check is let's go ahead and have it where sex is male. So I'll say where sex is equal to male. And so what I have now is this condition of total bills must be greater than 30. And let's say I also want to make sure that the sex of the person is male. So once I have these two conditions, I'm going to grab them, and inside of parentheses, because of Pandas syntax, you just have to do it this way, you pass in that condition, and then we also pass in inside of parentheses this other condition. There we go. And so then you have to decide, do you want both conditions to be true or just either condition to be true for your results? And in this case, I'll go ahead and say I want both conditions to be true. So only return the rows of the data frame where the total bill is more than $30 and the sex happens to be male. Now, a common mistake is people think they can just use Python's normal AND operator here, but in fact, you'll get an error saying something like the truth value of a series is ambiguous. So if we go ahead and run this with this kind of error, you'll see right here, the truth value of a series is ambiguous. And the reason it returns this is because the built-in and OR operators inside of Python, they're really just meant to compare two single Boolean values on either side. So is true and true, or true and false. And if we think about what is actually happening here, df total bill greater than 30, that's an entire series of Boolean values. And so Python is not smart enough to just understand and or comparing against two entire series of Boolean values. So instead, what Pandas does is it simply replaces this with an ampersand for and then this will automatically then compare all these conditions together. We run this, and now I get back the results where you'll notice everyone here is male, and also every bill is more than $30. So the main takeaways here are that you have the conditions inside of parentheses, and then you use either an ampersand, or if you want just either condition to be true, you can make this into a pipe operator. So run that, and this is OR. So you notice for all the rows returned, it will either be male, or it'll have the total tip greater than 30, or it'll also happen to be both. So either a condition needs to be true. Either they need to be male, in which case total bill doesn't matter, or the total bill needs to be above 30, in which case the sex doesn't matter. And so for something like this, you can have both of them be true. So either needs to be true, but they don't both have to be true, as we can see here and here. Okay, so that's the way you can add in multiple conditions, but I also mentioned you sometimes want to check or filter by a list of options. For example, let me go ahead and show you this data frame right now. If we see the head of the data frame, I could say that I only want values for the weekend, where the weekend is Saturday or Sunday. In which case, how would I actually filter out the data frame based off the day to only be Sunday or Saturday? Well, one way I could do it is, given what we just learned, I could say give me where df day column is equal to the string Sunday, or with a pipe operator, and let's make sure we don't forget the parentheses here for syntax purposes. And then the second condition I'm going to pass in, or df day is equal to Saturday. So what I have here, you'll note, is I'm basically asking, give me back the data frame where the day can be Sunday or the day can be Saturday, essentially giving back those weekend dates. So I have my Saturdays and Sundays here. And now let's imagine that I don't just want to check for 2 days, Sunday and Saturday, but now I also want to check for Fridays. Well, something I could do is just add another statement here of have this day either be Sunday or Saturday or, and then keep going here with day equal to Friday and so on. However, this sort of thing starts to get really annoying if we're always using the same column here, so you should note that, df day, df day, df day, and we're just comparing against multiple possible categories with OR statements. A quicker way of doing this is using the special isIn method, and it's an extremely useful method, and basically it just returns back a true or false if the values happen to be in a list of options. So the way I like to do this is I make my list of options. Let's go ahead and just make the list Saturday, Sunday. So here's my list of options, and then the way this works is you call in the column and then say isIn options. So what's actually happening here, it's going to return true or false if the value for whatever particular row it's analyzing in the day column is present in this list of options. It's the same thing as kind of saying is sat in the options list, and this will return back true, except it's just checking this for every single row value. That's what it's going to do with this isIn options parameter. So if we run this, you'll notice you get back true, true, and then some of them happen to be false on days where it happens to be Friday, which means I can then actually pass this into my data frame because it's simply an indexed series of Boolean values, and it will only return back the rows where this happens to be true. And then we do our filtering this way. So this is the .isIn method call where you just provide a list of options. You don't actually need to separate out as another variable. If you want, you could do something like this where you say, go ahead and give me the data frame rows where a df day happens to be in this options list of either Saturday or Sunday. It's a much faster way of writing out something like this, especially if you're going to be comparing against more than just 2 possible values. Okay, so that's it for conditional filtering. Hopefully you can see how useful it is. And coming up next will be a lecture series on a variety of useful method calls that we can work with on a Pandas data frame.